How's everybody doing? Welcome back to the Math 140 instructional videos sequence. Here we're going to be talking about, or start talking about, linear equations. So it should be a little bit of a review from your previous classes, but it'll move us along the way and where we want to go. Okay, so when it comes to linear equations, really there's generally some relationship there. All right, it's a relationship between quantities, and we could categorize it. So, for instance, in the metal field, you may need to understand how various quantities change with time or with respect to other quantities. For instance, when should a patient receive another dose of medication? Well, you need to understand the way drugs leave the body over time. Let's say you have two solutions, one 10%, one 30% concentration. We'll talk more about what that means later in a later video. But you need a solution with 25% concentration. How much of that you need? Well, you need to understand the way the concentration changes as you mix the two solutions together. Okay? So, first thing we want to do is, one of the most basic linear equations is one that has one variable, okay? And this is very deterministic. It's of the form ax plus b equal to c. Now, for example, if we wanted to solve 3x plus 7 equal to 6. Well, here we're going to use some algebra and use the idea, well, whatever we do to one side, if we do the same to the other, then the equality remains. Another way to say that is the relationship remains, okay? So here, let's say we wanted to solve this. First thing, hopefully we'd see, pause a minute, try solving it yourself. But we're going to subtract 7 from both sides, and that leaves us with 3x. Positive 7 minus 7 is 0, equal to 6 minus 7, or 6 plus negative 7, same thing, get negative 1. Now, last thing we got to do is undo. Notice, to undo addition, we use subtraction. To undo multiplication, you could do division. I do multiplication by the reciprocal. So some people may say divide both sides by 3. Saying the same thing as, say, multiply both sides by 1/3. 1/3 times 1/3 times 3 is 1. So x equals, and negative 1 times 1/3, negative 1/3. Okay. And here we see this relationship is saying x is a constant value of negative 1/3. Now, we really want to look at, well, what about when we're measuring two quantities? We want to find the relationship between two quantities. All right, here's an example where there's a relationship and it is linear. So suppose a backcountry skier can climb 1,200 feet per hour. She wants to summit a peak with an elevation of 8,700 feet. She starts at an elevation of 3,900 feet at 6:15 a.m. At what time should our skier expect to summit? Okay, so here, let's see. Well, let's not worry about equations and this and that for now. Let's just try and think about the problem. How many feet does the skier need to climb? Okay, well, wants to get to 8,700 feet, and it's starting at 3,900 feet, and that gives us 4,800 feet. That little tick mark means foot. To reach the summit. Okay? Reasonable. Okay, now I want you to think, how long is that going to take? Okay? we could piece it together a little bit. In hour 1, we go a distance of 1,200 feet. After hour 2, we've gone 1,200 plus 1,200, which is 2,400 feet. Hour 3, 1,200 plus 1,200 plus 1,200, or we've gone 3,600 feet. Oh, we're going to need one more hour, 4, and this is going to be bring us to 4,800. Oops, I put an extra 0 up here. This is 3,600. And then over here, well, 4,800 feet. So it takes us 4 hours to reach the summit. So we'd assume 10:15 a.m. Okay. Now this chart here, notice that 3,600 minus 2,400 is 1,200. 2,400 minus 1,200 is 1,200. That's really what it means to have a linear relationship. Is the change is constant each time. All right, this is by 1,200 every time, every hour. Right, it's 1,200 feet. Okay, so how do we relate this to, say, an equation? I mean, that is fundamentally what it means for two things to have. What are our two things that we have that are a relationship here? I would think of it as, so just take a moment, think about what are the two quantities that have a linear relationship? All right. Well, I think one big giveaway in a lot of problems is look at units and notice it's changing by 12 feet per hour. Okay, so that means that we need a relationship between feet and hours. Okay, so maybe we'll say let y equal elevation in feet after, let's say, x hours. Okay? And we're going to let x equal number hours hiking. Okay? Now, notice what's our linear equation here to represent this linear relationship is the elevation after x hours climbing is, okay, equal sign is always is, well, let's see, we're starting at 3,900 feet. Let's just write that down like that. Plus, what happens? So this 1,200 feet per hour, you may recall that's called the slope of a line. It's 1,200 feet per hour. And that is 1,200 and then times number of hours. And notice here, this is in feet, this is in feet, and this is in feet per hour times x is in, x is in hour. Okay. Oh, look at that, and the units cancel, and we got feet plus feet is feet. That's what we like to see with units. All right, so like I said, this could be coming back to you a little bit here, and maybe if I wrote this a little differently, it may really look familiar. Y equal to 1,200 x plus 3,900, and notice, of course, after when we plug in 0 for x, 0 times 1,200 0 gives us 3,900 feet. That's where we'd be at. All right, so what is this? This is in called y or slope intercept form, and we have y equals mx plus b. So here our slope is 1200, and notice that is feet per hour, and remember that's equal to the change in y, y2 minus y1 over the change in x. And notice the units are exactly what those are, the y units over the x units. Now, we have that all set up. That's our slope, and we call b is really 0. Sorry. 0b is the y-intercept, all right? Whenever x is 0, whatever that number is, b. In this case, 3900 is our y-intercept. Good. All right. So make sure you take a look at that. Maybe try the problem again, set it up in your way. But that's what it means to have a linear relationship between these two variables. Okay. Every time I go, remember what this means. I go up 1200 to the right one, and I'll be back on the line. Up 1200 to the right one, I'd be back on that line. And that's really fundamentally what it is to have a linear relationship. Now let's recall, again, some slides here. Recall that the rate of change of a quantity y over time period t0 to t1, right, is the change in y over the change in t. So if you travel 60 miles over 12 hours, what is your average speed? Well, let's see. The change in y, you went from 0 to 60. Well, you changed the change in y over the change in, I'll say t here, is equal to 60 over 12, which 60 over 12 is, what is that? 5? 5. And notice your average, it's your average speed, and that's 5 miles per hour. That's not saying that you were driving 5 miles per hour the whole time. There's lots of ways that you could have that average speed over 12 hours, okay? So most likely this person was not in a car. Maybe running, slow bike ride. But it's tough to tell. There's lots of ways that could look. Now, a linear equation in two variables is an equation that models the relationship between two quantities such that the rate of change of one quantity with respect to the other is constant. And going back to our example, y equal to 1200x plus b, or plus 3900 from our elevation gain, our backcountry skier there, we got that. Notice it's always 1200, all right? You're always going 1200 per one. 1200. Up here, it's possible in the first hour you went 20 miles. That's a possibility. Okay, down here, that's not possible. You go exactly 1200. Staying constant, that just means that the difference between evaluated at 1 and 0 is 1200. Of 3 and 2 is 1200. And for each change in 1 and x, we get a change in 1200 and y. All right, so it has a constant rate of change. Okay, since the linear equation models constant rate of change, the graph of the linear equation is a line. There are three possibilities. Let me just show you a picture, quick picture here of a line. Maybe something like y equal to 3x plus 2. Okay. And here the y-intercept is, there it is, 0, 2, like we would think. And the slope is 3. Up 3 over 1, and I'm back on the line again. If I go up 6 and over 2, I'm back on the line again. That's what it means to have that constant. All right. There are 3 possibilities. Horizontal, vertical, x equal to a constant. This is, we think of this as infinite slope, okay, because it's a vertical line. Horizontal is y is constant, so y equal to d, that's a horizontal line. And then neither, and that's what we're generally used to, where we have a slope equal to mx plus b. We have a slope and a y-intercept, all right? And by the way, that y-intercept could be 0. Certainly in that neither category would be something like y equal to 3x, just goes through 0. Now supposing the relationship between quantities y and x can be modeled with the linear equation, the rate of change of y with respect to x is called the slope. All right, and again, let's go back. Y equal to 1200x plus 3900. What is this slope in the context of the problem? It's saying that my skier climbs 1200 vertical feet for each additional hour that he's hiking. Now, if a line is not vertical, we saw in slides before that we could find this is the change in y over the change in x to find the slope, where x1, y1, and x2, y2 are any 2 points on the line. Notice that when x1 and x2 are equal, then the line is vertical and the slope is undefined, right? Super steep, vertical. To determine the equation of the line, you need 2 pieces of information, either 2 points or a point and the slope. Okay. And there's 3 common equations. I think you're probably most used to the slope-intercept form, y equal to mx plus b. But just the same thing. It's nothing different. It's just using the formula or slope. We have the point slope form. So y minus y1 equal to m times x minus x1. Or equivalently, this other one here. We'll just move the y1 to the other side. And then standard form. And each have their own uses. The standard form looks like ax plus by equal to c. Let's look at one example. So let's suppose that we have 2 points, 1, 2, 3, 6. They lie on a line. Find the equation of the line in slope-intercept form and then graph the line. All right, we have 2 points. We know that the slope is the change in y over the change in x, and that equals 6 minus 2 over 3 minus 1. As long as you stay consistent with your numerator and denominator and the order-wise, you're all set to go with the slope. Okay, so this is equal to 4 over 2, and that's 2. Oh, but now we have 2. Here is where I would use the point slope form, because I have the slope and I have 2 points, and that's going to be y minus my y1, let's say 2, equals my slope, which is 2, times x minus x1, which is 1. All right, and now we got to combine some terms. We get y equals to 2x when I distribute the 2. Don't forget that distribute, 2x minus 2. And add 2 to both sides, plus 2, and that gives me y equal to 2x. Okay. What that line looks like over here is it's going to go through the origin and have a slope of 2. Slope-intercept. And lastly, I'll show you a big Desmos. So hopefully we could see this well enough over here. I've got to sort out a little my technology for the next video. We'll continue on next time with a couple more examples. So you really this video and the next one should go fairly close together. And don't forget to ask me if you have any questions. Have a great day.